Jiajia from China Academy of Information and Communications Technology. My co-author is Chao. Our research name is Unravelling Dns Performance, a historical examination of F-route in Southeast Asia. First, I want to briefly introduce some basic knowledge about DNS. As shown on the left, the picture shows the conventional process of DNS query resolution. Thanks to the cache of the recursive server, most domain name query requests can now be responded to through the cache. But if there is no cache, the recursive server needs to query the authoritative name servers level by level. And the starting point of this process is the root server. So its resiliency is very critical. And so this is the root server. Presently, there are 12 ICANN authorized root operators responsible for managing a total of 13 root name servers, denoted from A root to M root. To be able to respond to a vast and continuous stream of questions, now it has passed 80 billion per day, as well as to resist various cyber attacks. The root server operators have met this resiliency requirement by distributing root server instances around the world using a routing technology called Anycast. Anycast routing allows machines all over the internet to use the same IP addresses to provide identical responses, thereby allowing root server instances to be located in hundreds and different cities and countries. As of mid-August, there are more than 17,000 instances, which we call root nodes in this research, deployed in 169 countries. Among A to M root, F root nodes had surged from 58 in early 26 to 505 in August 2023, marking a nearly tenfold increase. And among all continents, Asia leads the way with the number of F-root nodes growing from 15 in early 26 to 191 as of August 2023. So our research centers is focused on the F-root and select Southeast Asia as the primary research area. So here are some questions that we expected to explore through this research. First, how query latency changes with the number of F-root in Southeast Asia, SEA region, and individual countries. 2, does more F-root guarantee lower latency? 3, does more root servers contribute to higher domestic resolution rate? 4, should more F-root be deployed in SEA region or in any particular SEA country? Next, I will briefly describe how this study was conducted. Data we used in this study is sourced from Web Atlas platform. It is a global probe network designed for testing network connectivity and reachability. Currently, it has more than 12,000 of active probes distributed worldwide, and the number continues to grow. Among all SEA countries, we selected those that had more than 1 active probes in early 26 and has at least 10 active probes in August 2023. And meeting these criteria are only 6 countries, which include Indonesia, Malaysia, Philippines, Singapore, Thailand, and Vietnam. DNS measurements are built-in measurements of the web platform, and all data are publicly accessible. In this study, we collected DNS records from all probes in the 6 countries mentioned, sampled at regular time intervals from January 2016 to August 2023. In addition to RAPS data, we also utilized the historical archive data from the rootserver.org platform regarding the deployment of root servers, such as types and geographical locations of root nodes. After collecting all the data, we employed a relatively simple and straightforward method to identify and locate the responding root server. Put it simply, first we obtained the hostname of responding root nodes from the RAPS measurement records. And then we use the host name to match it with the identifier field in an archive YML or JSON data from the rootserver.org website. If the match is successful, it automatically identifies and locates the specific responding root node. So now we have everything, and it's time to do the research. In the first section, we analyzed the use of froot in SEN region, focusing on the number of nodes and the query latencies. In this chart, the black line signifies the number of froot, while the red line represents the average RTT, which is the returned scattered data points are visible in blue, where each point signifies the average RTT of an individual probe. Darker color indicate a higher concentration of similar RTT result. Generally, a denser distribution along the x-axis indicates better performance. At 2016, there were a few froot nodes deployed in SEA region. Before May 2017, some data points clustered at the upper part along the y-axis, mainly centered at 200 milliseconds and 300 milliseconds. In May 2017, 6 new froot added, leading to a noticeable change in distribution of data points. Near the x-axis, the color became darker, indicating a significant decrease in RTT. Over time, beyond 2020, the width of the distribution at the lower position gradually narrowed compared to the previous periods. However, with the number of froot nodes continued to increase after 2020, there was no apparent change in the distribution of the scatter points. In the next section, we analyzed the historical changes in query latency and the number of froot in 6 different selected countries. Observing each country individually, we can find, for Indonesia, the number of froot increased from 1 to 7. As the number of froot nodes increased from the trend of the red line, it can be seen that the average latency has decreased, but it is not so evident. For Philippines, before 2017, the Philippines had no domestic froot, resulting in a broad distribution of query latencies. It adds its first F node in April 2017. We can see a significant improvement manifested as a gradual decrease in points at higher position and an increase in points closer to the x-axis. But after 2021, the subsequent increase in the number of routes didn't bring continued performance improvement. For Thailand, initially the absence of froot resulted in broad latency distribution. In May 2017, Thailand introduced 2 froot, which improved the situation. Points in the upper layer started to decrease. By December 2017, the number of froot increased to 6, and we observed a continued decrease in points in upper layer. Meanwhile, points in the lower layer started to settle even lower. During the first quarter of 2018, points in the upper layer gradually decreased to near disappearance, and the points in the lower layer sunk to the very bottom. Afterward, the froot kept increasing, but latency didn't show significant improvement. The trend in the other 3 countries are basically similar, with the exception of Indonesia, who has already achieved good performance even at the start of 2016. A common pattern emerged for all other 5 countries, and it leads to the same conclusion as in the previous section, which is early introductions of root nodes consistently produced substantial improvements in latency, while later introductions had a more limited impact. In this third section, we examined the historical trends in the distribution of destination countries or regions, with each row representing a selected country and numerical labels at the top denoting the years, and the bottom number 1 to 4 indicating the quarter of a year. different colors representing the countries or the regions where responding root nodes are situated. To enhance clarity, we merge destination countries or regions with proportions below 1% into a single category labeled as others. And additionally, some responding root nodes couldn't be identified or located were collectively characterized as unknown in this study. From the graph, we can see that Singapore's F route, in this color, Singapore's F route is widely accessed. Apart from Singapore itself, queries from other 5 countries also access Singapore's F route during different periods, some with relatively high proportions. Malaysia's F route has also been accessed by other countries, particularly from 2016 to the third quarter of 2018, when it was among Thailand's top 3 destination countries for F route. In addition, Indonesia and Thailand's F route were briefly accessed by probes from outside their respective countries, but the proportions were so low that they appear indistinguishable in this graph. In contrast, Philippines and Vietnam's only have local type of F route, and their F routes are only accessible to probes within their own countries throughout the entire time span. And besides, we can say that in the early stages, notably in 2016 and 2017, except for Indonesia and Malaysia, the other 4 countries had a significant proportion of their F route queries routing to US and the Netherlands. And after 2023, none of the 6 countries had its F route queries routed to route nodes located outside of Asia anymore. The primary destination for F route in each country is now their own country, with domestic rates exceeding 90% for Indonesia, Malaysia, and Singapore and Thailand. But for Philippines and the Vietnam, these rates are lower at 63% and 46%. We speculate that this may be related to the adjustment of their teleoperators' routing policy. Besides their own country, these 2 countries primarily access the F routes in Hong Kong and Singapore. More nodes didn't bring higher domestic rates for these 2 countries. It may be intuitive to think that introducing more F route nodes would increase the proportion of responses from domestic route nodes. However, our findings reveal that as countries introduced more F routes, the proportion of responses from domestic routes didn't consistently increase. Instead, it fluctuated. Though the root cause of this phenomenon is not clear yet, we still think that countries may not necessarily need so many F routes. So in the first part, we focused on the data extracted from July to August of 2023 and plotted the most recent cumulative distribution function curves of RTT for each country. We can see that all countries have a proportion of RTT under 50 milliseconds, exceeding 90%. However, a closer examination of the proportion of RTT under 25 milliseconds, and this line, it reveals gaps among countries. Indonesia, Malaysia, Singapore, and Thailand constantly maintain proportions above 90%. In contrast, Philippines and Vietnam, while achieving good average RTTs, they exhibit room for improvement in reducing RTT variations, with proportions under 25 milliseconds at 79% and 53% respectively. So finally, there are the conclusions we reached through this research. First is regional improvement. The introduction of F route nodes has positively impacted the region. while the most significant improvement occurring in the early period, especially in 2017 to 2018. To geographical distribution. As F-route nodes increased, each country ended up with querying more of their own route. Presently, Indonesia, Malaysia, Singapore, and Thailand have domestic resolution rates exceeding 90%, while Vietnam and the Philippines lagged with domestic rates of 63 and 46 respectively. RTT CDF characteristics. Over 90% of queries had latency value between 50 milliseconds for all countries. However, Philippines and Vietnam exhibited significant lags when it comes to percentage of smaller latency values, like under 25 milliseconds. Philippines and Vietnam can still work to reduce their latency variances. So, given all the findings, it's our view that adding more F-route to these countries appears unnecessary, and we advocate for exploring alternative strategies such as implementing a local copy of the root zone file or optimizing the route strategy are worth considering for further optimization of the DNS infrastructure of the ASEAN region. So that's the end of my presentation. Thanks for your attention.